Hey everyone. Can you believe that we only have 3 weeks of class left? We only have 2 weeks of teaching and 1 week. The last week we will do our unit tests and that's all we're doing. But we only have 2 weeks of actual stuff we got to learn left. We have two topics left. One of the final two topics that we're going to talk about is compound events. And compound events are sort of trickily kind of easy but not so. Okay, let's first define it. Compound events. A compound event is an event, okay, that has two or more two or more simple events. Two or more simple events. Now, you remember that when we started getting into the probability things, remember I told you that the formula for a simple probability was just simply the probability of A happening was the number of desired outcomes over the total number of outcomes, right? Like rolling a dice, if we wanted a 3, there's a 1 in 6 chance of rolling a number 3. Okay, so compound events is when you have more than one of these at a time. Okay, you have more, and it's usually has to do with when you're looking at a chart of data or data, depending how you say it. That kind of thing. We don't really normally talk about compound events when we're rolling a dice or spinning a wheel, that kind of thing. Those are independent events, and we multiply the results together. Compound events, most of the time, you're going to add your results together, unless you unless you use the word and in the thing. Let me define those things for you. So first of all, let me give you a formula. Okay, so probability. So we're looking at compound events here. The probability of some event, probably of some event or another event happening. So the probability of A or B happening. Okay, we write it mathematically like this. We would say the probability of A, and I would use this symbol right here, or basically a U, B happening. Okay, and just take note that this symbol means or. It means this or that. So not both of them. One or the other happening is what we're asking. So we have a compound event and we're saying what's the probability that this thing happened or the other thing happened. Okay? And the way we would, let me go back to my rid. So the way that we would calculate this, if you see the word or, basically you know it means add them together. So the way we would figure this out is we would do the probability of A plus the probability of B. Now see how that's different from independent events where if we use the word and, right? This and that happening, you know in that case that you are using multiplication. You're multiplying. Multiply. Right? So when you see the word and, you think multiply. When you see the word or, this symbol, okay, and you remember was this symbol, an upside down U. So when you see and, you multiply. When you see the word or this symbol, you know you're adding together. Now, we do have to talk about two different situations that can happen in compound events. So the first situation that we want to talk about is what if we have an inclusive event? Okay, an inclusive event. We're still this is under the heading of compound events. We have this thing called an inclusive event. An inclusive event is this. This is an event that has one or more outcomes in common. Now, I know this doesn't make a lot of sense to you when you first see it. It will when we do the example. But let me give you a really easy way. This is all you need to remember to figure out whether you have, if you're talking about an inclusive event or not. Okay, super easy way. So in any chart of data, let's just pretend this is some sort of chart of data. It doesn't matter what it is, but we've got a chart of data here. This is a chart of data. Maybe it's ages. Maybe we've got different ages along the side here, and up here we've got flavors of ice cream. Flavors of ice cream. Okay, so I've got, chocolate, vanilla, strawberry, blah, blah, blah across the top. And I've broken people into age groups, 0 to 10, 10 to 20, so on and so forth. Okay, the way that you tell if you have an inclusive event, this is really easy. This is all you have to remember. The way you pick it out, okay, is if you ask any kind of question where one of the things is a row, maybe an age group, and the other part of your or statement is one of the columns. Doesn't matter which one of the columns. Okay, I want you to notice that right here, see what happened right here? They overlap each other right here in the right here where they cross paths. Whenever you see something overlap like this, automatically you know this is inclusive. And you have to be careful when you do your odds on an inclusive event, because if you don't take away one of the groups, then you're going to count the same thing twice and it'll throw your odds off. So you have to use a special formula when you do this. Okay, so when you're dealing with inclusive events, this is the formula that you're going to need to do. It's not just the common one that I just gave you, but it looks a lot like the common one I just gave, but it's a little different. So let's say that we ask the probability of some event or another event, and let's say it's just like this situation I just gave you in this chart, where one of the things is a row and the other thing is a column, and they overlap each other in one of the cells on the chart. They hit each other, okay? So if that's the case, it's still going to be exactly like this. You're going to do probability of A, and you're still going to add the probability of B, but you have to make an adjustment. You have to subtract the probability of A and B from your equation. This is, okay, the reason why I'm doing this is this thing right here, this thing right here. This is the common event. All right? In other words, the cell where they overlap, you have to subtract the value of that cell from your probability, because if you don't, then you've counted those people twice. And you're only looking, when you're doing this, you just want the totals. You want the total here and the total here for your probability. If you count the thing in the center as part of your totals, then you've counted the whatever it is in that thing, you've counted them twice in your probability, and it'll throw your odds off. So if it's an inclusive event, you have a row and a column, you have to add this part, this minus probability A and B, you have to add that to your equation, take it away. That's the first one. The second one's really easy. The second thing under compound events that might happen is you might have mutually exclusive events. Mutually exclusive events. Now these only happen when we use the word and. They don't happen when we ask the word or. Now these are easy to pick out as well. So if you're using the word and, okay, then by definition you have, for it to work, you have a row and a column, and these things overlap somewhere. If you ask a question where they're both rows, so they're both rows in your data, then we have a situation that we call mutually exclusive. That's where we end. So let's go back to my example up here with the age and flavors of ice cream. What if you ask the question, what if you just ask the question, what's the probability that if I pick someone at random that they're, say, between the ages of 0 to 10 and that they're between the ages of 10 and 20. Now remember, I'm picking one person at random. What's the probability that this person is between the age of 0 and 10 to 20? Well, you can't do that, can you? Because either a person's either in this group or in our thing, or they're in that group. They can't be in both. A person cannot be in the age group 0 to 10 and be in the age group 10 to 20. Unless they have a time machine, I don't see how they could do it. So we would call that a mutually exclusive question. In other words, you cannot answer this question. You would just say this is mutually exclusive. So it's a situation that we've set up. The question's asking something that's impossible. All right? And sometimes people do that. Sometimes people deal with data and they ask a question, and you have to realize, wait a second, we can't answer that question because the question you've asked is asking for a probability of something that it can't be two things at the same time. It's either in one group or the other. It can't be in both at the same time. We call that mutually exclusive. So that's your two situations. So in general, you're going to use this formula right here. Let me highlight right here. This one right here is generally the formula you're going to use, except for sometimes we have this thing called inclusive events, where they overlap each other, and we'll have to take away the probability where they overlap. So let's do an example, and hopefully this will make sense to you. I know the first time you see this, this is very confusing. Let's do an example and see if it'll make sense to you once we do the example. Let's pretend that we do a survey. We're going to ask people if they are colorblind. Okay, or the other choice we're going to give them, we're going to say, are you colorblind or are you not colorblind? So we're going to ask people whether they are colorblind or not colorblind. That's what we're going to ask them. And we're also going to ask them one other question. We're going to have a second set of data in here. We're going to ask them whether they're male or female. Maybe we're interested in maybe we're just interested in are males more apt to be colorblind than females? Maybe we're doing a little experiment on that and just asking people just to see kind of what are there more of one of the types of people? Are they more apt to be colorblind? Who knows? By the way, these numbers are all made up, so don't draw any conclusions from this. This is just totally made up. So we're going to have two totals. We're going to have a total for our total along here for our colorblind and not colorblind. We're going to add them up and get a total. And we're going to add our male and female people together and get a total that way as well, just like a two-way table, which we did a couple weeks ago. I'm going to give you some of the information. I'm going to tell you that in total, we interviewed 3,510 people. Out of these 3,510 people, there were 1,910 of them were male. Of the females, 6 of them were colorblind. And in total, the total amount of colorblind people that we got in our survey was 103. Now, if I gave you just that information, you should be able to fill in the other things. So that's your first task for me right here, is go ahead, pause the video, and see if you can fill in the missing blanks on this chart. So hit pause, and then come back and see if you got it right. All right, now when we did this a couple of weeks ago, I did show you. I gave you an example. I showed you how to a strategy to fill in things that we don't know on a data chart. And I told you that anywhere that you have only one missing space in your data, you can fill in. So this one's simple because we only have 3 spaces in any direction, right? We only have 3 spaces. But even if you have one that has 4 and 5 different things in your data, if you have any that only has 1 space missing, that's the one you want to start with. So we have our choice. We can do the column of colorblind because I have 2 of those, or I can do the column of the total, or I can do the row of the total. I can start at any one of those because I know the 2. Let's start with the male and colorblind. Male and colorblind. So if I'm doing the male and colorblind, I know that some number plus the 6 female colorblind people gives me a total of 103 people. Okay, I don't know how many males there were that were colorblind, but I know if I add that to my 6 females, my total is 103. Let's just work backwards. Let's just say 103 minus 6. That would give me 97. So I know that my males and colorblinds are 97. And we're going to do the other ones the same way. So let's see what we can do next. Well, if you look at the column, not the row, but the column for the totals, we see that we have this situation where we have 1,910 males plus some unknown amount of females gives me a total of 3,510 people. Well, again, let's just work backwards. Let's take our total amount of people, take away the males, and we'll know how many females there are. Okay, so 35, 10 minus 1910 is going to give me, did I do that right in my calculator? Yes, I did. 1,600. 1,600 females. Okay? All right. Where else can we fill in? Well, all the not colorblind people. If you look at that column of not colorblind people, you'll see that on either side we have 2 numbers in each one. So we'll just fill in each one. Let's start with the one on the top. Let's look at the top row. So I'm looking at the top row now. And I know that 97 males plus some unknown number of not colorblind males gave me a total of 1,910. So we'll just work backwards and we'll say 1,910 minus 97. Okay, so 1910 minus 97 gives me 1813. 1813. Okay, the next one's going to be rather easy because it's 6 plus some unknown number gives me 1,600. Well, 1,600 minus 6 would give me 1,594. And then finally the bottom column, or bottom row I mean, bottom row, we have 103 total colorblind plus some unknown number of not colorblind gave me in total 3,510 people. So just work backwards on that one. 3510 minus 103 gives me 3407. 3407. If you wanted to check your work, just to make sure that you did it right, you could pick one of the rows and add them up. Let's pick the not colorblind. Let's just make sure that 1813 plus 1594. Let's make sure that that really does equal 3407. So I'm going to put that in my calculator and double check it. 1813 plus 1594 gives us 3407. That's just a way to kind of double check to make sure we didn't mess up anywhere. Okay, so the numbers are working now. So we've got our chart filled out. Now let's ask some questions. Let's ask some probability questions about what we have in our chart. So the first question I want to ask is, we're going to pick up one person. We're going to pick one person at random from this data, and we're going to ask the question, what's the probability that the person I picked is a male or is colorblind? So the first thing that we have to do is we have to first figure out, did we ask a question that is inclusive? Did we ask an inclusive question? Now remember, I just showed you this on the other page of notes. We said that any time that something is a row and the other thing is a column, that automatically that makes it an inclusive question. So let's look at the males. So I'm going to use green. Let's look at the males. The males, as you will see, are a row that goes across. The colorblinds, let's use yellow. The colorblind, the people that are colorblind, you can see that that is a column that goes down. So they overlap right at that number 97. These two things intersect each other at male and colorblind, which is 97. So we are going to have to adjust our formula to reflect that because this is an inclusive event. So the way we're going to answer this question is we're going to say the probability of male, we're going to add to that the probability that they are colorblind, and then because they are inclusive, we are going to take away where they overlap. In other words, we're going to take away the probability that they are male and they are colorblind. If we do not take this last step, then we're counting that 97. We're going to count that 97 twice. It's going to throw our odds off by double, right? If we don't take that last step, we are counting people twice in the same category. And we don't want to do that because we want to ask if they're male or if they're colorblind. So what's my probability of being a male? How do I figure that out? What's my probability of being a male? Well, what's the desired numbers of outcomes of being male? How many males are there total in this thing? In total, there are 1,910 males. That's my desired outcomes, 1,910. Now, how many people in total were in the thing? 3,510. Now I'm going to add to that the probability of being colorblind. Now, what's the probability of being colorblind? So what's my desired number of outcomes? What's out of in other words, out of all the people, how many of them are colorblind? So in other words, when you're doing this step right here, when you're doing these things right here, okay, when you're looking at these things right here, you're looking at totals. You're only looking at totals when you do these things right here. So my total colorblind are 103 out of 3,510 people. Now, from this, I also have to take away the probability of male and colorblind. Okay, so that's where they overlap. That's the thing where they overlap. There's 97 male and colorblind out of 3,510. Okay, now hopefully you understand why we're taking away this way. Because in my 1910 and my 103, that 97 is included in both of those totals. So if I don't take one of them away, I'm counting them twice. And I don't want to do that. I want to get proper odds. So this is real simple. You see your denominator. Your denominators are all 3,510. So just take your calculator and just punch it all in at once. So 1910 plus 103 minus 97, okay, gives me a grand total of 1916 out of 3510. Now let's convert that to a percentage. Let's divide our 1916 by 3510 to get a percentage. So I'm going to round it. It's a decimal of 0.54. We'll go one more point, 9 if we round it. Okay? Which is, if we want to give a percentage, that as a percentage is roughly 54.9%. So if we were going to ask the question, if I randomly pick a person, the chances that they are male or they're colorblind, I got a 54.9% chance of getting someone that's either a male or they're colorblind. All right, let's ask another question. Let's erase this. Let's do another question. So that was an inclusive event because they overlapped. Okay, there was a row and a column in my question. Let's ask question number 2. Question number 2 that we're going to ask. Okay, what's the probability of being female or not colorblind? What's the probability of being female or not colorblind? So we know that right off the bat we do have to say the probability of female, and we have to add to that the probability of not colorblind. Now, if we're inclusive, then we got to add something else, right? But if we're not inclusive, that's my formula right there, and I'm done. I can just start plugging in numbers. But let's ask the question: is this inclusive? Inclusive? Question mark. Is this an inclusive question? Well, probability of female. Female. Okay, probability of female. Let's get rid of my other arrows here. Okay, so probability of female. You can see that that is a row. That's a row that goes across. What about not colorblind? Well, you can see that not colorblind is a column. So these things overlap. They intersect each other, which means yes, yes, this is an inclusive question. That means I need to, in my formula, I need to take away the probability of, oops, I shouldn't have put that. Wait, let me fix this. I need to take away the probability of female and not colorblind. I need to take away the cell in the data where these two intersect each other. I have to take that away from my thing or I won't get the right answer. So probability of being female. Now remember, we're looking at totals. What's the probability of being a female? Well, there was 1,600 females out of 3,510 people. I'm going to add to that the probability of not being colorblind. Okay, how many people were not colorblind? 3,407 were not colorblind out of 3,510. Then I'm going to take away the cell where they overlapped. Where did they overlap? They overlap at female and not colorblind. That's the cell right in the dead middle of the table there. That's 1,594 over 3510. Okay, and again, just take your calculator because you'll always have the same denominator in all these questions. Just take your calculator, add your numerators. So 1,600 plus 3,407 minus 1,594 equals, we get a grand total of 3,413 out of 3,510. That's going to be a really high percentage. So divide your numerator by your denominator, 3,510, and we get 0.972. 0.972, which as a percentage is 97.2%. Okay, now the reason why we got such a high percentage when we asked this question is because most people that we asked were not colorblind. So if you say female or not colorblind, that you're talking about almost everybody in the survey, because almost everybody was not colorblind. All right, let's ask another question. Let's ask something else. All right, let's ask the question, what's the probability that if I pick a person at random, what's the probability that this person is colorblind or not colorblind? What's the probability that a person is colorblind or not colorblind? Okay, well, colorblind is a column going down. Not colorblind is also a column that goes downwards. Okay, so we have two columns. Now, if we use the word or, and we have two columns or two rows, are these mutually exclusive? So you have to ask yourself the question, can a person be colorblind and not colorblind at the same time? Well, if we pick a person at random, okay, let's not get tripped up on our things here. It says the word or. So can a person be colorblind or not colorblind? Yes, that's possible, right? They can be one or the other, but this is kind of a stupid question, isn't it? The reason why this is a stupid question is because we've included every column there is in the chart. That's everybody in the chart. So you have a 100% chance of being either colorblind or not colorblind. So while it's not mutually exclusive, okay, it is sort of a stupid question asked because that's everybody in the chart. So it's a 100% chance of being colorblind or not colorblind. Okay, let's do one more question. Let's ask the question, what's the probability of a person being colorblind and, we'll change it, and not colorblind? All right, so when we use the word and, first of all, you know you would multiply your results together. If we use the word and, you know that means multiplication. Colorblind and not colorblind. But my problem is again, these are both columns, and a person cannot be both colorblind and not colorblind. So in this one, you couldn't answer the question. You would say this is mutually exclusive. We can ask an and question as long as one of them is a row and the other one is a column, but we can't ask an and question if they are both columns or both rows. We can't ask that type of question. It doesn't make sense given that we're using a two-way table. All right, I hope that wasn't too confusing for you. If it was, remember that I am online every day. Just join Teams chat. I'm available every morning from 9 to 10 a.m. I'm just sitting there in my chat. There's a few of you come see me regularly, but most of you, I never hear from you, so I don't know whether you're doing okay or not, or I don't know. I'm available every morning, Monday through Friday. I'll be on there 9 to 10. I'm also available. I'm online almost all day. You can just send me a message. If I don't happen to be sitting in front of my computer, then just wait. I'll answer you eventually. If I happen to be sitting in front of my computer, I usually answer you like almost immediately. But you can send me questions through Teams chat. If you really need help and you're really lost, you need to get on there so that I can video conference with you and we can actually, and I can use my little board here and walk you through stuff. Okay. Uh, these questions I have found in the past, a lot of students do tend to have a little trouble with these. You're going to try the worksheet that I have linked right beneath this. And just so you know what's going on this week, here is the schedule for this week. Hopefully you didn't stop watching the video yet because this is actually important. Okay, so Monday/Tuesday, depending on what day you logged in to see this. Okay, Monday or Tuesday, you're going to do this lesson and you're going to do some practice. You're going to do practice and then you're going to fill out what Canvas calls the quiz. All right, like we have been doing the last 2 weeks. This Friday, so there's not going to be a lesson on Wednesday. There's no lesson on Wednesday or Thursday this week. But on Friday, you will have to log in sometime on Friday. I will open, there's going to be an actual quiz. And by quiz, I mean an actual test grade. Something that's going in as a test grade. So not a quiz like Canvas calls a quiz, but like an actual real quiz. It's going to go in as in a test grade. It will only be available on Friday. Probably I'll do something like I'll open it between the hours of 8 a.m. to probably somewhere late at night. Let's say something around 10 p.m. or something. Okay. It'll only be available during these hours, and you must log in and take it during that time. It'll be timed. It'll be timed, and it will probably be multiple choice. It'll be multiple choice. I don't know how many I'm going to put there yet. Haven't decided. But it'll be multiple choice. It will be worth a test grade, so this is a chance to bump your grade because this won't be as hard as a unit test. It will only be on. It will not be on what we just did today. Compound events. Okay, so compound events are not on it. Okay, no compound event questions. It will be loaded with stuff like independent. If I could spell independent and dependent, it'll be loaded with these types of questions. Independent and dependent questions, the things we did last week. Okay, so no lesson. So just recap. We've got our lesson today. Do your practice work. Do your little quiz to answer the practice work. Then there's nothing on Wednesday, Thursday. You're just going to prepare for your test on a quiz. Not It's not really a test; it's a quiz, but it's going to be worth the test grade. That'll be unlocked on Friday. It's nothing. It's not. We're not talking like 30 questions here. It's going to be less than 10 questions. It'll be multiple choice. It will be timed though, and you will have to complete it on Friday. Okay, so whatever plans you had, make sure that you open up time on Friday. You have to do this on Friday. Okay, that's all I got for you. I guess I'll talk to you all later. Remember, I'm available every morning if you need me. Take care.